Alright, so I had this customer bring in this spiral scratch player, and from what I can tell, it works pretty well. It plays the songs. I think the speed's off very slightly. So as you can see, I'm in the 33 RPM mode right now, and just the nature of the lights that I have set up, you can certainly see that the 33 speed is running a little bit slow, regardless of where I put the pitch control. We'll switch it up to 45. We should go up 2 notches. You can see the 45 is running a bit fast, once again regardless of where I put the pitch control. So I need to troubleshoot that and find out what's going on. So here's the schematic for the turntable. The power supply down here looks like it creates 22 volts, a 110 or 220 switch depending on what winding of the transformer you're going to use. And so these are the motor driver transistors, the pre-driver and output driver right here, some inverter circuits, and they use a 555 timer IC for all this to happen. So it looks like the motor runs at one constant speed, and then they have a frequency generator over here that goes into a buffer to another inverter, another set of inverters, and they feed that back into the 555 timer IC depending upon what speed you have selected, 33 or 45, and then there's the master speed control pot. That's the one that's not working. So I need to determine what's going on here, because it's pretty close. It's just not getting this little bias this speed pot introduces into the circuit through this, what is it, a 110K resistor. It's a 5K pot, so they're just changing the bias a little bit into pin 5. So do we have a bad capacitor in here somewhere? I'm going to go ahead and try to get into this thing, and we'll do some ESR checks like always on some of the capacitors, a 220, a 0.47. Let's see if we can get into this thing and check some of these values and see what might be going on. Maybe it's just got a bad speed pot. Maybe that's all it is. Just a defective speed pot. I don't think the 555 is bad, because if that was bad, it wouldn't be giving me an output signal that would change between 33 and 45 when I switch the speeds. Okay, so I've got it open, and taking a look at this thing, I see a bunch of tantalum capacitors on here, a metallized film capacitor, and only 2 electrolytics right here. But we'll go ahead and check those just to be sure. Okay, so I've got all the capacitors marked. I did miss a 4.7 at 25 volts right here. Does not look like a standard electrolytic capacitor. But first, let's check lead integrity, make sure we get 0 ohms, and we do. So first, we'll check that 4.7. Oh, it's just about a half an ohm. That's perfectly fine. This is one of the tantalum capacitors right here. And we get about 6 ohms. The other tantalum, about 6 ohms. This will be the 10 microfarad 16 volt electrolytic capacitor, and about 3 ohms, perfectly fine for a 10. Back over here, we'll check the 220 at 6.3, and about an half an ohm, perfectly fine. And the last 2 tantalum capacitors, about 3 ohms. And now that one's about 18 ohms. I wonder what the value of that one is. Is it a very low value? It's a 47 at 35 volts. Let's go ahead and check ohms on the speed pot right here before we do anything else. And just make sure we get 5K end to end, and that we see a resistance on the wiper as well. Okay, so I'm on the auto ranging function right now, and so end to end, I see about 2K in charging, because it must be going across the power supply. So let's check end to wiper, and I see 2K in diminishing, the other end to the wiper, and I see 122K in dropping. That's a problem. So the pot's in the middle right now, so I should have about 2.5K on each end. So I'm going to go ahead and unsolder this pot, and we'll check it out of circuit. Okay, so I have the pot completely unsoldered from the circuit. Let's go ahead and check end to end. We should get about 5K, and I see 2.8K end to end. Now, according to the schematic, that should be a 5K pot. So now we'll check one end to the wiper, and I get nothing. So my lead integrity is good, the other end to the wiper, and I get nothing. So definitely having a problem with the speed pot. I've worked this pot probably 50 to 100 times, and I get nothing. And why am I getting 2.8K when it claims to be a 5K pot? And I think I know the answer to that, because the pot itself is stamped 2.5K. So they must have made a revision in the bill of materials to change that from a 5K to a 2.5K. Anyhow, 2.8K is within the range of tolerance, so it's just over 10% out of tolerance, but still I've got nothing to the wiper whatsoever. Okay, so just for the heck of it, I've got my ohm meter in the 60 meg range, which realistically it only reads up to about 40 meg, 40 million ohms, and I have it in min-max. So if I rotate this, I get absolutely nothing end to end. So without a shadow of a doubt, the speed pot is bad. Well, I've went ahead and removed the 3 spring clip retainers. So now this should simply lift off and out of the way. I can get to the nut and remove the pot completely from the unit. There it is, completely out. So let's see, is there any identifying marks on this unit whatsoever? Well, there's all I see. Ruido, R-U-W-I-D-O. On the back of it, I do see a number, 15.004.01. I see a couple of rivets here. I wonder if I can drill those out and get inside this thing and see what's going on. So let's try to do a little autopsy on this and see what might have gone bad. Alright, well I went ahead and drilled out the rivets that were in this. Let's go ahead and carefully take the back panel off. Right off the bat, I don't see any problems. So I'm going to go ahead and pull that C-clip off of there and see if we can get the wiper off completely and see what might be going on. Houston, we have a problem. The wiper, this portion right here, has become completely detached from the rotary portion. Here's the actual pot, and you can see I sprayed it with deoxit. So the way this works is these little tabs right here and right there actually ride against this ring right here. Now that ring is electrically connected to the wiper terminal, and so when those tabs ride across it, it creates a short basically from whatever position the wiper is in to this ring. So if you had the wiper turned all the way to this position right here, you would get basically a 0 ohm resistance from this terminal to the wiper back to this terminal, and then you'd have a 2.5K resistance from this terminal, which is the rest of the resistance ring over to here. So because this became detached, the wiper is no longer electrically connected to the commutator ring right here. So that is the problem. Unfortunately, there is no repairing that. Not whatsoever. The next thing I can do is I can try to find a pot with the same diameter and approximately the same protrusion to try to get it mounted back up in here. So let me see what I can come up with. Maybe we can get this customer back happy, get his spiral scratch player back up and running with an actual speed control. Alright, so let's try to get some specs on this. Main thing is going to be the shaft diameter. So 3.98 millimeters. So if I find a 4 millimeter shaft, we should be perfectly fine. And about a 7 millimeter thread size. So let's get on the old Googler and see what I can come up with. So from Mauser, I have selected a 91 U1A-T22-A13L. It's the only one I could find close to the description. Now this is a 5K, 5000 ohm potentiometer. Now the original one was 2.5K, but the service manual called for a 5K, so it might give us slightly more range. So here are the specs on it. It's a 91, which means a single turn inline with PC pins. We can solder wires to that. It's a U, which means a metal plane 7 millimeter diameter thread by 9 millimeters long. 1. It's a single pot. A. Single .305, 7.8 millimeter, or 90 degree and the length is a T. It's a plastic single slotted 4mm diameter. Now I would have liked to get a metal because the original one was metal, but I think plastic will work just fine. It does have a shaft length of 22mm, which means I'm going to have to cut it off. The original shaft was only about 6mm long. It's type A, which means a linear with 10% tolerance, and it's a 13, which means a 5K. Doesn't seem to be available in the 2.5K range. And it is an L RoHS compliant, which means it has no hazardous materials in it. So unfortunately, it is a plastic shaft style, shaft type T, 4mm, 3.988mm, with a shaft length of 22mm. And it is a model 91 with the plastic shaft. So I'm going to go ahead and quote this to my customer. We'll see if he chooses to go with the repair on this unit. And if that's the case, I will go ahead and get the part on order and follow up on this video. Well, take a look at what just showed up. 5K pot with the 22mm shaft. Definitely have to trim that down, but the bushing length and the diameter looks to be identical. Well, from inside the package at least. Comes with mounting hardware. Now it doesn't have the solder terminals, but it has leads that I can tack the wires onto. I think it'll be just fine. So let's go ahead and get this open up and trim the leads, cut the shaft, and install it in this turntable. So the nut that they supplied is much larger than the original nut in diameter. So let's see if the original nut is going to fit same thread size. Yes. Oh, that's going to be nice. So we can go ahead and mount this new one in there. I'll just have to Dremel off the shaft a little bit. Okay, so there's the new pot with the shaft cut down to length. Other than being plastic, it looks almost identical. Let's go ahead and get it installed and see if it runs. Alright, so since the leads on the new pot were so long, I went ahead and twisted loops into the end of them so I could tuck the wires through them and solder them to get a great mechanical and electrical connection. So the new pot's installed. Let's go ahead and install the turntable back in the base and fire it up and see if we get a speed difference now. Alright, here we go. 33 test. So speed control all the way to negative. Look at that slow down. So I'm looking at this one right here. So speed control in the center and speed control on fast. Look at that. Let's try 45. That's going to be this one right here. So speed control down. It's definitely slowing down. Speed control up. And put it right back in the center. Just the speed pot was bad. So let's put some vinyl on this thing, play a few seconds of music, adjust the speeds, and see if we hear a difference. Alright, I got K-Tails, Pure Power, 20 original hits, 20 original stars in stereo. Check that out. This is from 1977. I'll play a little bit. Slow it down. Speed it up. It works great. Let's put a 45 on it now and make sure it plays too. I have collectibles, Collector Series 45s. Who Loves You? The Four Seasons. Okay, here we go. Let's check the speed of a 45. Let's speed it up a little bit. Let's slow it down. So it's working absolutely perfectly. There's right on speed. There's fast. There is slow. So let's go ahead and let this play the whole record through. It'll make sure it picks up correctly at the end. Alright, let's see if it picks up now and returns back home. Yes, it does. Awesome. So this turntable is repaired. It sounds great. It works great. Once again, I want to give a sincere thank you to those who have supported my channel with a donation via PayPal or by having me repair your unit like this one. If you enjoyed this video, please consider subscribing to my channel and liking this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter, at NorCal715. You can email me, norcal715videos@gmail.com. Go ahead and leave me a question, a comment, a concern down below. I try to read all the comments and respond when I have time. Remember, with your help, we can keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Once again, thanks for watching this video. I really appreciate it. Everybody have a great day. Bye-bye.